Hello and welcome to this video. In this video we're going to be looking at SI units and their prefixes. So this is in the topic of measurements and errors. So when we are doing physics, we are primarily trying to get some understanding of what's happening in some system, whether that's a small quantum system or that's the universe as a whole in cosmology. We're always trying to get some understanding, and we do this numerically. And to do this numerically, we have to make certain measurements. And these measurements that we make could be different. And the way that we can, so for example, if I wanted to measure some distance, okay, so I measure the distance of this line, not drawn accurately, to be 10 meters, okay? And then somebody else comes along and they say, oh, that's not 10 meters, that's 32 feet. While both of these things seem to be very different numbers, they're actually measuring the exact same thing. But because the units are different, we would say that these two things don't agree with each other. And so if we have scientists from all over the world who are all recording measurements, how do we make sure that all of these measurements are accurate to each other? And the way we do that is the French came up with a system that we call the SI system, okay? And they said that this system is the system of units that we're going to use as a base system. Now, in practice, not everybody listens to this, but this is what we're going to use for A level. So the SI system means that all of our measurements have to be in 7 base units. So we have some base units, and they describe what is the base unit of length, what is the base unit of mass, base unit of time, temperature, current, luminous intensity. This one you're not going to have to worry about at A level. Luminous intensity and amount of substance. Okay, these are the 7 base measurements that you will encounter in physics in general. Okay, for the purpose of A level, we can ignore luminous intensity. Okay, that's not going to come up, but the rest of these units will come up. So what this means is whenever we have a length, we always measure it in meters. Whenever we have a mass, we always measure it in kilograms. Time is always in seconds. Temperature is always in Kelvin. Current is always in amps. Luminous intensity would always be in candela, but again, we're going to forget about that. The amount of substance is always in moles. Okay, these are our SI units. If we ever have any other units, so for example, if we looked at the units of velocity, they're just made up of 2 of these things, because we know velocity is just the distance over time, which is a length, which we measure in meters, divided by the time, which we measure in seconds. So we get our units are built up of these base units. Sometimes you will see that there will be other general SI units. These are the base units. Okay, so this is, if we were to break it down to be as small as possible, what would the very building blocks of each of these units be? So an example of something that we could see like this is the charge. Okay, the charge, we've said we're going to measure in coulombs. Okay, but if we think about what a coulomb actually is, we know that current is equal to charge over time. So the current is actually equal to, the charge is equal to the current multiplied by the time. And so this is actually amp seconds. Okay, so 1 coulomb is actually the same as saying 1 amp second. Okay, so this is just our idea of this. Now, when you're asked to write answers to this, you'll always want to put them into these units, but we sometimes will have to convert between different magnitudes, because if we think about measuring the radius of an atom, it's going to be a very, very small number if we measure it in meters. And so what we can do is we can use this idea of introducing some prefixes that make the number somewhat understandable. Okay, and so we have a list of prefixes. So we start at the very center. So we're going to start with just meters. So we start with just meters. Okay, now I'm going to do this in meters, but this could be a prefix for any of these SI units. So if this was a prefix for the amount of time, we could have the exact same things. So meters, we're going to do this in powers of 10, is just going to be 1. Okay, so it's going to be 10 to the 0, essentially, but this isn't going to matter too much. Okay, if we wanted to go a little bit bigger than meters, we would go into kilometers. Okay, so I'm going to get rid of this meters, and I'm just going to have the prefixes. So kilo means 10 to the 3, because we know kilometers are 1,000 meters, so it means we have 1,000 of whatever our base SI unit is. We have 1,000 of those, so we put a kilo in front. If we wanted to go even bigger, we would have a what we call a megameter. Okay, so we'd have a megameter, which is 10 to the 6. If we wanted to go even bigger, we'd have a gigameter, which is 10 to the 9. And if we wanted to go even bigger than that, we would have a terameter, which would be 10 to the 12. Now notice these are actually always going up in the threes. So it goes from 10 to the 0, 10 to the 3, 6, 9, 12. We could go further than this, but you'll find that generally we'll stop at gigameters or giga coulombs or giga, whatever it is. But we could also go much smaller than this. So if I wanted to go smaller than a meter, we could go to a millimeter. And we know that in 1 meter there are 1,000 millimeters. So this would be 10 to the minus 3. If we wanted to go even smaller than that, we can have micrometers. And micrometers are 10 to the minus 6. Nanometers would be even smaller at 10 to the minus 9. Then we could have picometers at 10 to the minus 12. And finally, femtometers at 10 to the minus 15. Now, you probably won't encounter many of these repeatedly. Okay, so let me point out which ones are the important ones. Kilometers will happen to come up a lot. Millimeters will come up a lot. Nanometers will come up a lot. Femtometers you're only ever going to look at in particle physics. Nanometers you tend to look up at when you're looking at wavelengths of visible light, tend to be in nanometers. Micrometers you tend to have to look at when you're actually doing practicals, because we tend to use micrometers, and they can measure lengths to the nearest micrometer. And millimeters, meters, and kilometers are always going to happen. Okay, so these are our prefixes. They all have symbols. You'll never see them writing out kilo or any of that. So obviously the middle one doesn't have a symbol. Kilometers we would put with a little K and then an M. Mega is a big M. Giga is a big G. Tera is a big T coming down. Milli is a little m. Micro is the Greek letter mu. Nano is a little n. Pico is a little p. And femto is a little f. So if you have something that is saying, let's have a femto amp. Okay, this is ridiculously small, but this would just be 1 amp. So let's say we had 1 femto amp. I could write this as 1 times 10 to the minus 15 amps. We'll usually get amps to be milliamps, or sometimes microamps. Let's say I had 1 gigasecond, I could write that as 1 times 10 to the 9 seconds. Okay, and these two sides of these mean exactly the same thing. These are just converting between the two. You can be asked to do this in most calculation questions. They tend to be able to give you almost like a trick in the question where you have to make sure you're reading it carefully, make sure all your units match, and make sure you get them all into the base SI units before you start working out any of the values, because if you then find a value, you'll find that working out how to convert between two different unit systems is going to be much harder than converting each into the unit system and then trying to do it all at the end. Okay, so this is SI units and prefixes. Thank you for watching.